It's an integration by parts. Now this involves the product of two functions, neither of which is the derivative of the other, or derivative of part of the other. Remember, we had that prior to this in integration by substitution. But this is the case where we don't have that being able to occur. It's related to the product rule in differential calculus. We'll look at that just now. But here are some examples. X cos x. I cannot get x or some constant times x from differentiating anything there. I cannot get x squared from differentiating anything there, whether it be the sine of 5x or the 5x. I cannot get the x by differentiating here. And I cannot get e to the x by differentiating here. So that and that are unrelated, 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 unrelated. So therefore, they can't be substitution, and we get to hope they are by parts. Now, I did say that this is the equivalent of product rule. So let's have a look at product rule, and we're going to reverse it. So the derivative of uv equals u times derivative of v plus v times derivative of u. I'm going to change the order a bit. So all we've done is moved sides. Now, if this equals that, then the integral of this equals the integral of that, except this will have constant. There'll be a constant, but there'll be a constant built in because we'll still have an integral on the next line. So let's integrate. Now the integral of a derivative gives you back the original function plus c. And the c is going to be built into there. So we're going to end up with, that's going to stay integral u dv. This is going to become just uv, because I've integrated a derivative. Plus c, but in fact, integral v du, and this will bring in our c that we need. Has a nice pattern to it. Integral u dv, uv minus integral v du. Easy enough to remember, actually. So, it's a case of recognition. There we have our first one. X, nothing to do with sine of x in terms of derivative. So, we need to select a u and a function v, where the u is to be differentiated. Have a look. U, and then derivative of u. And the v is already a derivative. Because have a look. dv, u dv, u dv, or u dv, whichever way around I go. And there is v, which means that this would need to be integrated. V, this would need to be integrated. So let's let u equal x and dv by dx equal sine of x. So we choose that as the already derivative, which means du by dx is 1, and that means du equals dx. Sort of like multiplying up the dx. Not that it does, we can do that, but in this process it's fine in terms of substitution. And of course, this tells you dv equals sine x dx. Well, dv is sine x dx. U x, so it's related there. And of course, if dv equals sine x dx, v is equal to, and we integrate the sine x, and we get minus cos x. You don't have to worry about a c because that'll be coming in anyway. It'll still be inside an integral sign, which is going to introduce the c. So our formula, uv, so it's going to be x times v minus cos x. There we are. Minus integral of, there's the integral, v, which is minus cos x, there's your minus cos x, du, and we found du equals dx. Let's just tidy up a bit. That's fine. Finished with that. Shelve it for now. This we need to go further. Well, the integral of cos x we know is sine x, and there comes the c. Now there's a very easy way to check this, especially in an examination or test situation. When you're in an exam or test, if you're checking, it's better to try to check by some other method, whether it be substitution when you're solving equations or whatever. Because if you use the same method to check, you could make the same error. Well, there's an easy way to check an integration, and that's to differentiate it to see if we come back to the original. So there we are, I've differentiated this. I differentiate that by product rule. Derivative of x, negative x times cos x. There we are, negative 1 cos x. Plus negative x times derivative of cos of x, plus x sin x. Plus, because derivative of cos x is negative sin x with the negative x. Plus cos x, and that becomes x sin x. Look, minus cos x. And we have there, so we say, yippee, we have the correct integral. That's the skill, recognizing which way around. Well, if you have a look at this, if you choose x as the already derivative and you're going to integrate it, you're just going to bring in more, bigger and bigger powers of x with sin x. Just this is alternating between sin x, cos x, negative sin x, negative cos x, whatever. And if we have a look at it, let's try it. There we are. I've let u equal the sin x and x equal the dv by dx. Now have a look at the working here. There, v is equal to x squared over 2 because dv by dx is x. And if we have a look at our very first line of the formula, we now have integral of x squared over 2 cos x. And we're not getting anywhere. It's just being compounded. So we know that this direction of choice is not going to be working. So we're going back to let x equal the u and sine of x to be the dv by dx. Right, let's have a look at this one. We're going to do the same thing. We'll let u equal x squared, and dv by dx is sine of x, which means du by dx is 2x and du is 2x dx. So in the formula where it says du, we're going to put 2x dx. dv by dx equals sine of x, which means dv is sine x dx. Well, there you are, if sine x dx. And v equals, and we integrate that and we get minus cos x. So, applying the formula, integral u dv, integral x squared sine x dx. There we are, we have the correct place. You see, there's u and there's dv. X squared sine x dx. So, it's equal to u is x squared. du is 2x dx. v is minus cos x, and again v is minus cos x. Simplifying it a bit, notice it's good to bring constants to the front of the integral sign. It avoids confusion. Now we have to do this one again by parts again. Same process. So we end up choosing that as u, and that is our dv by dx, which means you'll have uv, which is u times v, which will be the integral of cos x, minus integral of v, there we are, because that's dv by dx, times du, which is 1x dx. And we simplify, we end up with that. Remember, the integral of sine of x is minus cos, so we'll end up with plus 2 cos x. Let's differentiate, and if you differentiate it, you'll see it comes straight back to x squared sine of x. You've got to try it yourself, pause, and just have a look at it. This is an interesting case because no ways, this can't be part because there's only a single term, but we don't know the integral of ln of x. So we're going to do something very interesting. We're going to let ln of x equal ln of x times 1. It's still ln of x, and this might seem stupid, but this is an amazing move. So we're going to let u equal ln of x and dv by dx equals 1. Meaning du by dx is 1 over x, and meaning du is dx over x, or 1 over x dx, and dv equals dx, and v equals x, where we integrate dv by dx to get x. Now we can apply our formula. uv So ln x times x minus integral of v x du 1 over x dx. I'm going to write that at the front because I never know whether that could easily be ln of x times x, or it could be ln of x times x, ln of x times x. So let's bring that to the front so we know where it's separated. Integral of 1 dx, well, that's just x. Testing, you'll see we'll come to the same thing. Pause it if you like, try differentiating, and you'll see you'll get right back to ln of x. Phew, you'll see why I say phew now. But this is also by parts. We're going to let u equal sine of x. Now you might think that's interesting because of course we're tempted to do that. But it doesn't matter which way around. It actually doesn't matter. We could have gone the other way too. Which means we have du equals cos x dx. And v equals e to the x, because derivative of e to the x is e to the x, integral of e to the x is e to the x. And we have dv equals e to the x dx. So applying our formula, integral of e to the x sine of x, well, integral of e to the x, well, there's the sine x, and the dv is e to the x dx, which means we're right. uv, so it's going to be sine x, there it is, times v, which is e to the x, minus integral of v du, and du is cos x dx. Now we need to go a further step by the same process. And have a look at this. This here is going to come straight back at us and give us a minus integral e to the x sine of x, which we take to the other side, we have two of them. Try simplifying that out yourself, you'll see that. So we brought it to the other side, two of them, and now we just divide by 2. Notice C1, because the integral C1 is introduced where we integrate. But now, that one there, when we divide by 2, we'll call it C2. Differentiate, and you see you'll come back to the start. So as soon as you see an e to the x and a sine or cos x, you know this is going to be this one where we go around in circles and then bring it across to the left. Here are some exercises for you to try. Pause, try them yourself, and then the answers follow. Merely substituting into the formula, and if you try differentiating this, you'll get straight back to the original. X squared e to the x. Well, I've got to get rid of the x squared, so I'm going to choose the u as the x squared, and it's going to happen twice. Notice I put this in green. This is simplified. Now all I'm going to do is I'm going to integrate that by parts again. There we are. Definitely going to choose u as ln x because the derivative is 1 over x dx, and that simplifies considerably when it's multiplying the dv by dx. differentiate to test. Amazing if that goes to this. We had one similar, x squared cos x earlier. This is also going to have to go twice. So there we are. Now the blue part is going to have to go again. There we are. Now, you need to remember something. Lots of people get stuck here when they try to find the integral of sine squared. They have a problem. Unless you remember the technique to integrate either sine squared or cos squared. And it all comes back to double angles. But let's determine our u and v first. Right, notice that dv by dx is sine squared, so v equals the integral of sine squared. And here's your reminder. Cos 2x is 1 minus 2 sine squared, and that's adjusted to sine squared x equals 1 minus cos 2x all over 2. And we use that, you see. Instead of sine squared, 1 minus cos squared x, cos 2x all over 2. You can separate it into two separate integrals, which is that. Now we got to keep that because that needs to go into our formula. So let's go back to here now. There it is. We have uv. So there's the u, there's the v coming from there, minus integral of, and there's the u, 1 dx, and there's the v, the integral. Simplifying that, we end up with the integral of two terms, and there is the integral of those two terms. Pretty straightforward, and it simplifies to that. Last one. This is going to be that roundabout pattern where you've got to bring to the right. So let's u equal e to the x and du equals e to the x dx. dv by dx is our cos x, so the cos x is already a derivative. Bringing it back again, dv cos x dx, and v equals, and we integrate cos x. So there we're applying into our formula. uv minus integral of, and there is our u, du is e to the x dx, and there is our v. Now that we need to do it again by parts, and we end up with that. Now have a look at the greens. They're like terms. If I bring this across, I'm going to end up with two of them. Divide by 2. Notice C1 there, but now it's just C because it's half of C1. And there we have it.